All right, find your seats, get out your homework.
And then I have a headache now. McKinley's smashed his elbow into my temple.
Hello.
Yeah, he got. That gravel hurts when you're like
Hi, Mr. C.
All right, any questions on the homework before we grade? No questions on the homework before we grade. All right, settle down over there. Sorry. There are things that I can control, and there's things I can't. That's one I cannot control. All right. Everybody has your homework in front of you. You're grading. Chris, where's your homework?
It's a real one, Chris.
All right. Here we go. I'm going to call these off quickly. All right. Number 2, y equals 26. Number 4, x equals 12. Number 6, n equals 112. Number 8, x equals 44. Number 10, y equals negative 77. Number 12, z equals 14. Number 14, b equals 114. Number 16, x equals 33. Number 18, g equals 12. Number 20, x equals negative 8. Number 22, h equals negative 2. Number 24, y equals 2.7. Number 26, these are the ones that, these are technically two-step equations here. Number 26, y equals negative 12. Number 28, y equals negative 7. And number 30, y equals
21.
no. No. 21. You can tuck your shirt in.
Yeah.
All right. Rowan, you got that under control? Thank you, sir. Okay, everybody look at the calendar real quick. One sec. We got a quiz next Wednesday. Next Wednesday. Here is your homework. Copy down.
Okay, so me and who are supposed to do the
Okay,
homework
sit. Copy it down.
Yeah.
And don't forget, I will never forget to put a 0 in your grade. Don't forget, I will never forget to put a 0 in your grade.
Oh, yeah, I know.
Yes.
I'm not even asking.
Do what?
Oh, dang. He snatched me. Josie. No, just do it on your waist for that.
Hey, I need boys. You too. Grab them, take them to the nurse. I know that was a sexist thing, but
I was like, oh, thanks.
Sexism in the classroom could definitely be you.
I'm just gonna say, you know, if it turned into I got to carry someone, then you'd be out there in the hallway asking for help. So.
I'm also hurt.
You're hurt as well too. Are you the next one to go?
No, I just went to the nurse. I'd probably be the next one to go. I got hit in the head.
What the heck were you guys doing? Throwing rocks?
No, it was
No,
soccer.
everybody's
We
retarded
played
when
soccer.
it comes to playing soccer.
Okay, no, we were supposed to have team sport day, and she was like, "No, we have to play soccer." No, it's team sport day.
All right. Who just threw the piece of paper? Please fix that.
I'm mad.
All right, here we go.
Wait.
All right, so I'm going to warn you again, the same warning I gave you yesterday. Now today I usually run into some kids who are like, I really don't know how to do this one. I don't ever run into that when we do addition subtraction. We're going to spend time on the correct procedure to solve one-step equation involving multiplication and division, Most of these you can look at, you can do in your head. Some of these you can't. But I'm teaching you the procedure, the correct way of writing it. I don't know, the step 1, step 2, step 3 type thing. We're eventually, starting tomorrow, we're going to move on to 2, 3, 4 step equations. Next week, we're going to be doing lots of steps. The time that we spend yesterday and today doing these things correctly are going to pay off when we do 4 and 5 step equations. All right, here we go. So it's not called, if you look in the book, it's not called solving 1-step equations part 2. That's French for 2. Thank you, boys. It's called transforming equations, again, another one. But yeah, it's going to be a 1-step equation. It'll only take 1 step to get to the answer. And we'll be solving it using multiplication and division. All right, quick note. Remember, as we get into next week and we're doing ones like this, some of you, when it takes 3 steps to get to the answer for some of you, I highly encourage you to draw a line straight through the equal sign, straight down. That will visually separate the left side from the right side for you. Sometimes the equation, you'll see it next week, it's really messy. And you're kind of like forgetting what's left. Put that away, please. You're forgetting what's the left side, what's the right side. Put it away. Put it away. Thank you. The book uses the abbreviation LHS and RHS for left-hand side, right-hand side. Okay? All the equations we deal with are called algebraic. That means it has at least one variable. Not this chapter, but very quickly, we're going to get into equations that have more than one variable. I'm not talking about this. Hey, you got 2 variables. No, it's just x. We're talking about we're going to get equations that have an x, a y, and by the end of the year, we're going to have x, y, z, p, d, q, everything, right? Lots of things. Okay? But the basic definition of the things that we're trying to solve is an equation that has at least one variable. Those are called algebraic equations. We're not going to write this down, but remember the 3 key ideas. Key idea number 1, Tristan, is?
I know it.
Well, then say it. What's the goal in algebra?
To get an answer.
And what does that look like?
X equals.
To get the variable by itself. All right. The second one is whatever you do to one side, even when it's the wrong thing, you got to do it to both sides. As long as you're doing the same thing to both sides, eventually you'll get to the right answer. Clearly, you got to do the math right, but I haven't shown you, but I will. Not on 1 step. I'll show you on 2 step. You got to do the same thing to both sides. So to get rid of things, that's the goal, to get the variable by itself, we do inverse operations. Inverse operations. There are more than 4, but at least until next chapter, we will do only 4. To get rid of addition, you subtract. To get rid of subtract, you add. To get rid of multiplication, you divide. And to get rid of division, you multiply. Those are the 4 of many inverse operations. All right. The words that I want you to think of when you're solving any equation are this. Is the variable by itself? This is when I say, hey, where's the variable, left or right side? And then I say, is it by itself? I'm giving you that first question right here. The second question is, well, since it's not by itself, what's attached to it? Hey, there's a 2 and a 6 over there with the x. So then I say, well, pick one of those, the 2 or the 6, and let's get rid of it. In order to do that, you got to say, well, how is it attached to the variable? Is it attached by addition, subtraction, multiplication, division? Once you determine that, then you simply do the, I don't want to say the word opposite, but it's called the inverse of it. And we just went over the 4 inverses. Okay, so I didn't have you write that down, but when I walk you through a problem, this is what I will be telling you. The only addition is I say, which side is the variable on? And I stopped doing that. You want to know why? Because in Algebra 1, guess where the variable will be?
On both sides.
On both sides. So I don't even ask you that. I just say, where's the variable, right? Well, it's on both sides. Okay. We'll talk about what to do when it's on both sides next week. Okay. So with that out of the way, we can review what we did yesterday. Chris, you're up first. Where's the variable, left or right? Right. Show me your 2 hands like this. 2 hands. Which one says L? Look at your fingers.
Wait, I'm sorry. Did I say right? I mean L. I mean left.
Yes, okay.
L.
So look at the left side. What's attached to it?
Addition.
What is attached?
2.
How is 2 attached to the x? How do we get rid of addition?
Subtraction.
So what are we going to subtract from both sides?
2.
So we subtract 2 from both sides. This is visually how it must be written. 2 minus 2 is 0. We know that. The reason why we did that is to get rid of 2. I don't need to see the 0 here, but I do need that. 5 minus 2 is 3. So the final answer is
3.
okay. 3 equals x, or x equals 3. Notice I skipped the step where it said 0. Yeah, I'm going to be doing that from now on. Okay. So that was a quick review of what we did yesterday. New idea. All right. Notice, Piper, where's the variable? Left or right side? Okay. Is it by itself, or is there something attached to it? What's attached to it? What number's attached?
2.
Okay. How is 2 attached to p? Now notice there is no symbol here, but we know when there's no symbol and a number is next to a variable, it means multiplication. How do we get rid of multiplication? So especially the new kids, look at the board. Piper said we need to get rid of the 2. The 2 is attached to p by multiplication. The inverse of multiplication is division. So what are we going to divide both sides by? The number you're trying to get rid of, 2. Occasionally I have some kids like, I don't know, divide by 10. 10 is not attached to the p. 2 is. So we're getting rid of 2. It's attached by multiplication, so we use division. This is how you write it. You don't write division symbol p. What do we write? We write it with a fraction bar. Is that how you were taught as well? Right? Okay. So I don't know any math teacher that doesn't teach it this way. So we attach it with fraction bar 2. Okay, Mike, 10 divided by 2.
5.
Okay. Here is the key here, right here. What's 2 divided by 2? It's not 0. Because if it was 0, then 0 times p would be 0. It's 1. Your math teacher probably said, cancel this. Here's what cancel means. It means it's equal to 1. 2 divided by 2 is 1. This slash that we put through. Nathan, is this how you were taught last year? Put a slash through it? Okay, how were you taught? Okay, so here's the way we're going to do it. When you have it at this stage, well, I'm pretty sure they probably did it like this though, right? How do you get rid of multiplication? So how did you write it? I bet that you did this. You write fraction bar 2 on both of those terms right there. 10 divided by 2 is 5. 2 divided by 2 is 1. Most math teachers say, well, cancel the 2's. What they really mean is 2 divided by 2 is 1. That's just a big number 1. 1 times p is, Nathan? What's 1 times anything? So what's 1 times p? You said it right, buddy, the first time. You said 1 times anything is itself. So what's 1 times p? P, okay? Now, the first time, at least today, I'm going to write that out. I don't know of anybody that actually writes this out in real life, right? When you cancel it, this is why most students think it turns into 0, because it like poof goes away and you're stuck with p. Why? Because 1 times p, as Nathan said, is p, right? So 5 equals p. Yes? Okay. Remember, not for this one. A check step is one where you take your supposed answer and you throw it back into the original equation. The original equation was 10 is equal to 2 times p. We're claiming that p is the number 5. Let's see, what's 2 times 5? Somebody?
10.
Yeah, 10 equals 10. It's checks, right? Nobody does a check step with a 1 step. When we get to 3 and 4 step equations, it kind of makes sense. If you have time on a test or quiz. Okay, here we go. Kaylee, where's the variable? What's attached to it? How? So what are we going to do to both sides? Both sides, 5. All right. Julie, where's the variable? Left or right side? Through your hands. Which one says L? Okay. So left side, what's attached to the variable? Do you see the variable? Do you see it? What's attached to it? How is the 6 attached to x? How do we get rid of multiplication in algebra? What are we going to divide both sides by then? Okay. Did your teacher tell you to use the division symbol like that last year? So I'm telling you to do it that way. There is another option. Watch me. I could write divided by 6. That works for the right side. Why doesn't that work for the left side? There's no space here. I can't divided by 6. It looks messy, right? This is why I don't know of any math teacher that teaches it this way, right? Every math teacher that I've known says put a fraction bar 6. Okay? Yes? Julie, what's 6 divided by 6? So, did your teacher tell you to cancel the 6's at this point with a big slash? I'm telling you to do that. 6 divided by 6 is this slash, except the slash doesn't mean slash. It actually means, 1. And 1 times x is x. Negative 42 divided by 6 is, somebody? Negative 7. So we get x is equal to negative 7. This step right here, just like yesterday, I showed it to you. X plus 0 equals negative 7. I'm going to show it to you today, and then I'll stop showing it to you. It's just extra work because the canceling does make the 6's go away. It doesn't turn them into 0. It turns them into a 1. 1 times x is x. Who's lost? All right. Clearly, Nathan, Julie have admitted that this is not the way they did it last year. So for you guys, you got to do it differently. Rowan, I didn't ask you. Yay or nay? Is this how you did it last year? This is how you did it last year? Okay, I think I've covered all. Mike? Okay.
No, I did not do this.
Yes, I'm going to throw something at you. All right.
How do we divide fractions again?
We'll talk about that in a second. That's the good one. All right, box 3. Let's do it together. Here we go. Box 3. Let's see. For those of you that are left-right challenged, where's the variable, left or right side? It's on the left side. What's attached to it?
-3.
It's not that 3 is attached to it. It's negative 3. Like what? That's just minus 3k. Well, all of that is true. But let's get rid of the 3 and the minus sign all in one shot. So we're going to call it negative 3k. So we're going to get rid of negative 3 in one fell swoop. Okay? Otherwise, it would take 2 steps to get rid of the 3 and then get rid of the negative. All right, so negative 3 is attached to k through multiplication. So what are we going to divide both sides by? Not by 3, the number we're trying to get rid of, which in this case is negative 3. Hey, I'm going to talk fast unless you stop me, new kids. Returning kids, we did this last year.
No, we didn't.
No, we didn't.
We did.
Well, new kids, most of them did it last year. Okay. Let's see, what's a negative divided by negative? So what happens to the negative 3's over here? It turns into positive, and they really turns into positive 1. They cancel each other out. Negative 3 divided by negative 3, the slash means for number 1. What's a negative 42 divided by negative 3? Therefore, the answer is
14 equals P.
Equals,
Whatever.
I don't know, because it was part of the previous one.
Oh.
All right. We good?
No.
Yep.
All right. Rylan asked a better question, but we're not there yet.
I was joking. I still don't do it.
I know, this year you're going to learn it. Next year you were exposed to it. This year you're going to learn it. All right, do box 4, please, all by yourself.
Okay.
Since no one asked the question.
I got this.
I know you do.
I promise.
Nice.
As you like really call me, so like do it together. That make any sense to you?
No.
Okay. Because if you had taken Algebra 1, it would. So I will occasionally get kids, like, especially when I teach this class, are like, I'm in the wrong class. And then all I have to do is open the book and say, have you ever done this before? Because we will be doing that this year. But clearly I'm doing a review of last year's stuff before we get to the new stuff. Well,
Oh, we kind of did.
Yeah, we kind of got not that intense, but kind of. Like,
What's the answer? This is an easy one.
can I write it down?
Sure. Oh, by the way, this is one you would do in your head. Because it's that easy.
Oh, it's 0.
It's not 0.
What's the line? The answer is 0.
The answer,
Just
well,
finding
it's
X.
equal to 0, but that's not the answer.
Oh, wait, no, I can't.
This is generally the problem I show a kid, and I'm like, can you do that? Any kid that has done that before will immediately tell me the answer. Well, that's why I know you haven't had this before.
Ha. Okay, so what is
You guys will all be able to solve this by Christmas time. But not now. The answer is -3, -4, by the way.
Oh, I see.
You probably don't see, but you will.
You have to,
Then you don't see
root it to
So
get-
you.
No, but that's a really good guess. It's not what you do for this one, but that's a really good guess. And it's an appropriate guess, too.
Do you have to isolate both the X's?
The answer to that is no,
No.
right? But it's a good guess. What are you doing?
I'm on board.
All right, Chris, you got the first one? What's the answer?
I don't know.
So why are you sitting there doing nothing?
No, it's he always does. It's a lie.
All right, Chris, walk me through it. You ask me the questions, and I'll give you the answers. But you got to ask the questions like I ask.
Okay.
Remember the 4 questions?
Yeah.
So you're me and I'm you. Go.
Oh, all right. Left side.
It's on the left side.
Okay. What's attached to it?
-6.
How's it attached to it?
Attached by multiplication.
How do we not make it?
We do division.
All right. What do we do with division?
So what do we? We're going to divide both sides by -6.
Right.
Keep talking.
-6 divided by.
I think that's 1. So it would cancel. And -96 divided by -6 would be a positive 16. Is that right?
Yeah.
16. All right. So that was a good job, you being me, right? And I'm just going to say, if you can do that, you can solve any of these, because those are what you have to say to yourself each time you do this. That was perfect. And like I said, yesterday, I have no kid that does it wrong when I ask those questions. Now, could you do the math wrong? Sure.
Yeah.
But show me you know what you're doing, and you're going to pass the course, right? You're not going to make that many mistakes. All right, Porter, bottom left. Talk me through it. Now you're going to be you and me together. You're just going to talk. Okay? Perfect. Good job. We got this, everybody?
Yeah.
All right. Last 2 answers are T equals
3.
T equals 3 and T equals 7, or 7 equals T.
16.
We good?
Yes.
All right. This was Ryland's question. All right, everybody stop, look at the board. I do need to show you this. Okay, the questions don't change. So Chris, once again, walk us through. You ask the question, the class will answer. Go.
All right. Oh. Okay. Where's the variable?
Class,
The left.
left side. Keep going, Chris.
All right. What's attached to it?
9.
How's it attached to it?
Division.
All right.
So you multiply.
So we.
You say, how do you get rid of?
So how do we get rid of division?
Multiplying.
So what are we going to multiply both sides?
So what's 9 times 3?
All right, before you do that, though, so that was good up until that point. So we decided that we're going to get rid of the 9. It's attached by division. Everybody stop doing it with the board. You will make a mistake on this. We agree that we're going to multiply both sides by 9. If you put this times 9, guess what you just said the answer is?
81.
Well, that isn't. We're trying to get rid of the 9. So it's not a question of on the right side what to do. It's easy, times 9. It's on the side with the fraction. If you put the 9 next to the 9, you're saying the answer is 81 of something. Technically, it's 1 over 81, 181, right? So the 9 needs to go in the numerator. The fraction bar extends. Now look at it. What does it say now? 9 times x divided by 9. We multiply both sides by 9. But what's 9 divided by 9?
1.
So it cancels. Let me make it nice and pretty for
I
you.
knew it.
Okay? So, Ryland, this was part of your question, right? 9 divided by 9, right, is 1. It cancels. So you're left with 1 times x. Why did I put this little thing here? Because remember, we multiply with fractions. We need to multiply by other fractions. Okay? 1 times x is x, so x equals 27. Yes?
Yeah.
Yes.
All right. Once again, a check step. We're claiming 27 is the answer. 27 divided by 9 is, in fact, 3. Okay. All right, here we go. Sierra,
Yeah.
this one's yours.
Okay. So you're going to put 4 next to the variable.
A 4. I'm trying to get rid of.
Negative 4.
Negative 4 is what I'm trying to get rid of. One side or both
Out,
sides?
and then you times negative 4 by 5,
Okay.
which equals negative 20.
And therefore the answer is,
X equals negative 20.
because the negative 4's cancel, 1 times x is x, so x equals negative 20. Got this?
I'm kind of doing
No,
it.
duh.
All
I
right.
feel smart. Can I do that?
All right, box 5. Go ahead, Tristan.
Okay, so the variable is on the right side. So it's attached to -7,
That's to x by.
attached to x by division.
Keep talking.
We're going to multiply 7 times 2, which is 4.
We're going to multiply what?
7 times 2.
What number are you trying to get rid of?
7.
We're not trying to get rid of negative 7. So what are we going to multiply by? You always going to add, subtract, multiply, or divide by the number you're trying to get rid of. What are we trying to get rid of?
-7.
So what are we going to multiply by?
-7.
Negative 7, not 7. So we're going to multiply both sides by negative 7. Messy, messy, messy. What's a negative times a negative? So their answer is
14.
14 equals x, because the negative 7s on that side would cancel. Cancel just means negative 7 divided by negative 7 is a 1. That big long slash there means 1. 1 times x is x. So x equals 14, or 14 equals x. Yes?
Can I
What
go
in
to
the
my
world
math?
is wrong with this class?
Can I go to my math?
Because everybody's retarded whenever they're playing soccer.
My nose got cut by my
Let's use the appropriate word.
Mentally slow.
Okay.
Can I go to the gym to get my mask? Because I forgot.
Are you bleeding?
No, but Yes. it's irritating, but it's digging back into my nose where it cut it, so that's fun.
Okay.
Don't wear a mask.
I can give you a Band-Aid.
No, mine, yeah, I need a Band-Aid. That's
All right.
Mr. Sorrell.
Mr. Chartier, but
Can I go to the gym and get my mask? So
My leg's broken.
where is your mask?
it's in the gym.
Why did you leave it?
I don't know.
All right, let's finish the class and then we'll do that. All right, here we go. Box number 6, you have 4 problems. Do them, please. Chris, make sure you do them this time.
8 equals 42.
Yeah, but do the work with the steps. Once again, yes, most of you can look at this and tell me the answer, but I need you to write the steps. Tomorrow when we do a 2-step equation, you have to have the steps written. You're not going to be doing it in your head. Anyone lost who needs help? All right, where's variable left, right side? Okay, what's that?
What's the next one?
So I'm getting rid of division. Multiply both sides. Got 7.7.
What is
Next to the so multiplication.
This is show you. Hold on.
I didn't know we had an intercom. Oh, you're talking about online. Yes.
So for number 16, I feel like you're going to explain this, but it has, like how this one you have the variable over the number. Well,
Correct.
For this one, it's 2 numbers and then the variable.
Heck yeah, I'm going to explain that next.
Okay.
Good question.
I had
Oh,
a
that
feeling you were.
All right. What's 7 divided by 7? Cross it off. 7 times 6.
Okay, so what'd you get for the last one? I got 1,000. The last one.
Where content?
I was going to run today, but I was like, I know.
85. That's super.
I would have
Or
put the
that's
60
12, right?
Just remember, negative times a negative is 0. Positive times a negative is 8.
No, that's we got one My ankle.
No.
All right, here we go. Look at the board, please, so we can get to the more challenging one. First one, the answer is A equals?
It's 42.
Or 42 equals A either way. Okay? Why don't you do the math? Bottom left, the answer is D equals?
16.
No. Don't drop your negatives. A negative times a positive is a negative. Upper right, M equals?
10.
You did division instead of multiplication. 40 is the right answer. And the last one, D equals?
1,000. Negative 1,000.
Negative 1,000. So now let's answer Ryan and Haley's question in a second. But first, let me show you this. Look at the board. Look at the board. You see this negative? Where does it go? Does it go in the middle? Does it go with the X, or does it go with the 7?
7. Middle.
The answer is yes to all of that. It is your option. Now, please pay attention. I don't think I have all your attention. Tonight for homework, you're going to get ones that look like this. Notice the previous ones, if the denominator was negative, I put the negative there. Tonight, homework, you're going to have the negative in the middle. Right? It is your choice whether the negative goes on the X, or whether it goes on the 7, or whether it goes in the middle. What's your best choice? The denominator. Because then we can get rid of negative 7, and we've killed 2 birds with 1 stone. If you put the negative on the X, or you leave it on the middle, then we're going to be multiplying both sides by positive 7, and you'll still be left whether you guys are not paying attention. And stop. If you leave the negative in the middle, or you put it on the top, then you get rid of a 7, and you're still left with that negative. Put the negative on the top. Remember, I'm sorry, bottom, denominator. Remember, when the negative is in the middle, green, you have those 3 options. It's better to make bottom option choice when you're solving algebra, because then you get rid of negative 7, and you're not left with a negative. If you leave the negative on the top, you multiply both sides by 7, you're still left with a negative up there. So we're basically getting rid of 2 steps in 1 when we put it in the denominator. This is a misnomer in the sense that you can have a negative on the top and the bottom. But the problem is, if you put a negative on the top and the bottom, what's a negative divided by a negative? So this is really positive 8x over 7. Like, why would I ever do that? You'll see why you would do that this year. But when there's only 1 negative, there can only ever be 1 negative. As soon as you put 2 negatives, you turn the whole darn thing positive. All right. So for this one, to solve it, first step is to put that negative on the bottom. Okay? Then we're multiplying both sides by negative 7. And like I said, we get to the answer in 1 step. Okay? All right. I'm going to skip this since you guys are wanting more and show you this. So in math, going forward, even if I'm not your teacher, you're going to hear this word cancel. Cancel this, cancel that. The word cancel only applies to multiplication and division. It does not apply to addition and subtraction. Okay, the one on the left, what do we do to both sides? What do we do? We subtract 6. You are not canceling the 6 here. You're subtracting 6 from both sides. When you do that, you do in fact get a 0. Well, x plus 0 is x. This is not canceling. This right side is canceling. When you divide both sides by 6, this slash is the canceling. 6 divided by 6 is 1. When a math teacher or you from now on talks about canceling, you're talking about dividing some number by itself. Okay? And yes, I will get on your case if you say cancel the 6's, or I canceled. No, you didn't cancel them. You subtracted 6. Canceling turns into a 1. This turns into a 0. Okay? All right. So now to answer Ryland and Haley's question. What's that? What is this?
Division.
Say it.
A fraction.
What is it though?
Division.
Okay, all that's true. I should ask the question better. No, what is this fraction?
4 over 5.
4/5, right? Okay, 4/5. What's the reciprocal of 4/5? Just flip it. Oh, by the way, this was a question on the quiz the other day. Correct? I asked you to make one reciprocal. You better have gotten that one right. I'm now debating whether or not Sierra got it right, since she didn't know what a reciprocal was.
I did.
Right? What's so special about a reciprocal? What happens when you multiply with reciprocals?
Oh.
It cancels.
Yeah.
So when you multiply with a reciprocal, it gets rid of the, well, it basically turns it into 1. 20 divided by 20 is 1. It cancels. So this is the answer, Haley and Rylan, of what do you do with the ones that look, oh, by the way, what's the reciprocal?
Negative.
5/4.
Okay. Cross canceling just turns into 1s. Okay. So this is, how does this help for the ones that look like this? Rylan, this was your question. Okay. So what number am I trying to get rid of here? I'm trying to get rid of 2/3. 2/3 is a fraction attached to a variable. How is 2/3 attached to the variable? So how do we get rid of fractions attached by multiplication? Divide. Copy dot flip means copy multiplied by the reciprocal. What is the reciprocal of 2/3?
3.
3/2. So the ones that look like this, everyone pay attention. Because you can have fractions on both sides. I will see mistakes here. Like, I forgot which one to flip. The one that you're going to flip, the one that you're going to multiply both sides by, is the one that's attached to the variable. Nathan, what number is attached to the variable? What's the reciprocal of 2/3? That's what we're going to multiply both sides by. This gets messy. Notice I have to rewrite it because it's that messy. All this mess, look at the right side. 3 divided by 3 is 3 divided by 3 is 2 divided by 2 is, these cancel each other out. It just turns into 1, 1 times t. On the other side, can you multiply 8 times 3/2? Or do you need to turn 8 to a fraction? How do you turn 8 into a fraction? Put it over 1, multiply straight across. 8 times 3 divided by 2 is, okay, or you can do some cross canceling. 2 goes into 2 once, 2 goes into 8, 4, 4 times 3 is 12. Either one of those works great. I multiplied straight across. 24 divided by 2 is 12. Yes? All right, this is how you separate I'm with the class or I'm not. If all you just heard in the last 5 minutes was blah, 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 you're not doing what you're supposed to do as a student. When you get to something like this should not be new, by the way. We did this last year. But your job as a student is you turn your brain on. Some of you need it on the entire class. Some of you can like on, off, on, off, on, off. Like, okay, got that one. He's going to do 4 more examples, but I understood it on the first one. All right, as long as you're quiet, you turn your brain off, I'll live with that. But some of you need to have that brain turned on the entire, all 4 examples. Okay? Let's do one first and I'll answer your question. All right, this is box 6. Let's do this. Box 6. Chris, get your paper out. We're doing box 6. This is going to be ugly this year because, unlike last year, we're going to throw in positives and negatives. Julie, where's the variable? Left or right side? What's attached to it? Okay, and it's attached through. So as soon as you see fraction attached to variable through multiplication, we know we need to divide with a fraction. We're thinking reciprocal. Notice there's 2 fractions here. This one's even uglier because this one is a mixed number. You can't multiply with mixed numbers, by the way. You got to change it into a improper fraction. Which is what?
24/4.
Which is what?
24.
Which is what? 25/4. Bottom times whole number plus numerator all over denominator. Big circle. 4 times 6 plus 1 all over 4.
Oh, I remember that.
All right. Always, 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 if you ever see a mixed number, just change it to an improper fraction. Yes, there's some that you can add. You can't multiply or divide with mixed numbers. Can't do it. You can only do it with improper fractions.
I mean, unless they want to get it wrong.
Well, as soon as I see you doing math with mixed numbers, I don't even look at it. Right? All right, so this is what I did. This is a mess. This algebra 1's a lot of mess. Okay? We already said, Julie said, we're going to multiply by the reciprocal, which would be negative 4 over 1. Hey, that's what I did, negative 4 over 1. Both sides by negative 4 over 1. Big, hot mess. Be careful. The cool thing is on this side, we already know it cancels. Negative 4 divided by negative 4 is 1. It cancels. 1 divided by 1, it cancels. All of that cancels. By design, on this side, be careful. You want to cross reduce or multiply straight across? What do you want to do? Cross reduce or multiply straight across? All right, let's cross reduce. What goes into 4 and 4? What goes into 4 and 4? 4. 4 goes into 4, cancels. 4 goes into 4, but that negative is still there. What's a negative times a positive? Okay, so 25 times negative 1 is, well, that's easy. S equals, and you're done. Yes? These are the ones that we get issues with. All right, here's a more friendlier one, box 9. Where's the variable? What's attached to it? Okay, are we paying attention?
Yes.
Right. I will certainly grade some people as more challenging, maybe not give as many free points for partial credit if every single day in class you're the ones not paying attention. And yet you think that you're paying attention. All right, here's the variable. What's attached to it? It's a fraction. As soon as you see a fraction attached to a variable, you're thinking what? Reciprocal. Multiply by the reciprocal. So what are we going to multiply both sides by? The thing that we're trying to get rid of in the reciprocal, so negative 11 over 2. It's messy, right? So we got to multiply both sides by negative 11 over 2. Ugh, that's a lot of mess. The only cool thing is that by design, this one cancels. And we're not going to multiply by something that doesn't cancel. So by design, that hot mess right there goes away. It turns into 1, technically. 1 times P is P. Over here, anything reduce? Cross reduction? What? 2 and the 14. What goes into 2 and 14? 2 goes into 2. 2 goes into 14. Okay. Where's my cross reduction? Oh, it looks like I multiplied straight across on that one. So for us, we turn that into what? Final answer?
-77.
Now it turns out that negative 154 divided by 2 is negative 77. Cross reduction will save you a lot of work. I would highly encourage it. I'm not sure why I didn't cross reduce on that one. Okay, that was it. All right, we have 6 minutes left. All right, actually 8 minutes, including your 2 minutes. All right, so go ahead and get out your book. Get started on your homework.
What is the homework? Oh, it's right there.
Haley, any questions? Haley doesn't want to talk today.
Oh, sorry, I didn't realize you were talking to me.
You're the only Haley.
There's no other Haley in this class.
She's coming back Monday.
Yeah, that's true.
The other Haley will be, and it will become confusing.
Yeah.
No.
No, I don't have any questions. You answered my question.
All right, cool. See you later.
Yep, bye.